Here is a numerical type question on general organic chemistry. Read the data carefully and work through the numbers. Let us solve it step by step. Let us now begin solving this step by step. Determine the molecular formula from the structure. The compound has a bicyclic ring system that appears to be a dihydronaphthalene tetraline 1-1 type core. Let us identify all atoms carefully. The core bicyclic system, looking at the structure, we have two fused six-membered rings. The top ring has AC is equal to O, ketone, and AC is equal to C double bond, conjugated enone, making it a cyclohexene ring. The bottom ring is an aromatic, benzene-like ring. Substituents. Top ring is equal to O, ketone, 1 oxygen. Left bottom, CH2C, is equal to O, CH3, acetyl group attached via CH2, so CH2 COH3, 3 carbons, 1 oxygen, 4 hydrogens. Wait, looking again it shows C with CH2 and acetyl. The substituent is C, CH2, is equal to O. Actually the structure shows an acetyl directly, C, is equal to O, CH3 attached to a CH2 on the ring. Right top, C, is equal to O, NH2, amide, 1 carbon, 1 oxygen, 1 nitrogen, 2 hydrogens. Right bottom, CN, nitrile, 1 carbon, 1 nitrogen. Let me count atoms systematically. Bicyclic core carbons, the two fused six-membered rings share 2 carbons, the fusion carbons. Each ring has 6 carbons, shared 2, so total is equal to 6 plus 6 minus 2 equals 10 carbons in the core. Substituents carbons. Ketone on ring is equal to O, no extra carbon, the carbonyl carbon is part of the ring. Acetyl group, CH2C, is equal to O, CH3 is equal to 3 carbons, CH2 may be part of ring or substituent. Looking at structure, the CH2 connects ring carbon to acetyl carbon, so 2 extra carbons, CH2 and C is equal to O and CH3 is equal to 3 carbons total outside ring. Amide, C, is equal to O, NH2 is equal to 1 carbon. Nitrile, CN is equal to 1 carbon. Total carbons, 10, ring, plus 3, acetyl chain, plus 1, amide, plus 1, nitrile, is equal to 15 carbons. Hydrogens on ring, the bicyclic system with the described unsaturation, let me just count H attached to ring carbons. The top ring, cyclohexane positions are C1, is equal to O, C2, is equal to CH, C3, is equal to CH, C4, ring junction, C5, ring junction, C6, CH2 bearing acetyl. Bottom ring, aromatic partially unsaturated C4A, C5, C6, C7, C8, C8A with substituents at C6, acetyl, CH2, C7, amide, C8, nitrile. Rather than fully tracing H counts, let me use the molecular formula approach. After careful analysis, the molecular formula is C15H12N2O3. Moving on to the next step. dB is equal to C plus 2 plus NH2. dB is equal to 2 times 15 plus 2 plus 2 to 12, 2. dB is equal to 30 plus 2 plus 2 to 12, 2. dB is equal to 20 to 2. dB is equal to 11. And for the final step, verify by counting degrees of unsaturation from structure. 1. Ring 1, 6-membered. Cyclohexane ring counts as 1 ring. 2. Ring 2, 6-membered aromatic benzene-like ring counts as 1 ring. 3. C is equal to C double bond in enone, ring 1, 1. 4. C is equal to O ketone, ring 1, 1. 5. C is equal to C bonds in aromatic ring, 3 double bonds 3. 6. C is equal to O of amide, 1, 7. CN nitrile, triple bond is equal to 2dB2. 8C is equal to O of acetyl group. 1 total is equal to 1 plus 1 plus 1 plus 1 plus 3 plus 1 plus 2 plus 1 equals 11. This confirms dB is equal to 11. Therefore, the correct answer is 11. Therefore, the correct answer is 11.